So on the left side in blue, we have our recursive formula for arithmetic. We're adding that to our notes today. We're going to be using recursive. And way over here in blue is the recursive formula for geometric. We're adding these two formulas, which are in blue, that one and the first one. And that's all we're covering today. It's going to be recursive. All right, first example, this is just a level 1. Now, that's another thing we need to add. To each one, if you're doing recursive, they have to give you the A subscript 1 definition. You have to have a starting place. So I'm going to add that. They will give you A subscript 1. That'll be given information. So I'm just going to add that A subscript 1 is given for them. You have to have a starting place for this to work. All right, and then they want us to find the fourth term. All right, what's the pattern? Right here, what's the pattern? Does it fit the geometric mold or the arithmetic mold? Arithmetic, right? Why? What symbol gives it away? The plus, right? If you're adding or subtracting, it's going to be arithmetic, and then we're clearly adding 4 here. Okay, so we know we're dealing with arithmetic, and the pattern is plus 4. So if you have a starting point, each term after is what? If you follow the pattern. How do you get to the next term? If you follow the pattern. Using the pattern, you're just going to add 4. Okay, this is nothing that we haven't really discussed. We're just kind of wording it a little different. We're just going to follow the pattern and add 4. Well, it says here, okay, first we want to identify the pattern, and we did that. We need to know what we're working with. Everything we've been doing is identifying patterns, doing patterns, everything for these sequences. And here we noted that plus 4 means we're doing arithmetic. Plus 4 is the pattern number. Okay, great. What are we looking for? What is it asking us to find? A subscript 4. What does A subscript 4 mean? We have a list of numbers. Where would that one be? A subscript 4.
The first.
Would not be the first. The first one is the first one.
The last.
Remember, how about the fourth? They're in order by their number. This is the one we have to find. So we determine a couple things. First of all, you need to determine what is the pattern, what are we dealing with. It's relatively obvious because they just say it's right there. With each of the 2 equations or formulas for recursive, you're just going to add or subtract a number if it's arithmetic over and over again. The same number. It's kind of boring. Same with geometric. We're just going to multiply by the same number over and over again. It doesn't change. Just the same number gets multiplied from term to term to term to term. The problem is, for us to find the fourth term, we have to have a starting spot. Does anybody know what the starting spot is for this particular problem?
The first one.
Well, what is the first one?
A.
And do we know it?
Yeah.
Where? How?
Because it says it.
It says it. It's given. Remember I mentioned that a second ago. I said, there's one thing I forgot. Whenever we're doing recursive, we have to have a starting spot. We don't know what it is. It has to be given, okay? Or if you were to write a recursive formula, you would have to lay down the starting spot for somebody to be able to use it. Our starting spot for this problem is a 7. We're seeking the fourth term. What are we going to do? Why? Why would we add 4? You're right, Eric.
Because it says plus 4.
It says plus 4, and plus 4 is the pattern. It's the common difference. So how do I find the second number? Renee? What is the second number? How do we find the second number? What is this? What is the second number? Huh? Yes, correct. 11. Okay. We're a little bit closer. How about the next number? What's the next one? Correct. And how about the fourth one? Anybody? 19? Are we done? I know it's first block. I know it's Monday.
Yeah.
Okay. So those are all the things you have to do. It's going to be like that pretty much every time. So we're supposed to find the fourth term. It tells you it right here. That's the question. You have to identify three basic things. First of all, which one are we doing? Right? What is the pattern? Those are kind of the same questions. If it's multiplication, you're doing that kind. If it's adding or subtracting, it's this kind, arithmetic, right? So what are we doing? What is the starting point? And where are you trying to go? It's kind of like determining a goal in their life. Where are you starting? What are you going to do to get there? And how do you know when you've gotten there? All right, so let me clear this. Show solution. Let's see what they did. Again, they did the same thing. You had a starting point. They apply the pattern to it over and over and over again until they got to the fourth term. Final answer is 19. Any questions? This is kind of easy. Kind of. You know, I think we can all kind of do great on this. All right, cool. See if you can do this one. There's too much stories. Okay, so where do we start? A1, it's 2, right? You start at 2. What type of pattern we deal with? What do you say? What kind of pattern do we have? The pattern, I'm asking for what is the pattern? It's plus 2, right? Okay, good. So is it geometric or arithmetic?
Arithmetic.
You're confident in his answer? Maybe? You're confident in your own? It's plus 2 each time. It's arithmetic because we're using addition or subtraction. Okay, so we know where we're starting. We're starting at 2 because it tells you 2. There's a lot of 2's in this particular problem. We add 2's each time. And where are we going? What are we trying to get to, Katie? What is the question asking us to find, Kinsley? A subscript 6, which means what? Anyone? What does A subscript 6 mean? Find the sixth term. All right, so the first one is 2. It might be helpful to write some down. You might think, I already know this one. Maybe you do, maybe you don't. 2. And then we got to go, okay, 4, 6, 8, 10, 12. That's 1, 2, 3, 4, 5, 6. A subscript 6, the answer is 12. This time it worked out because it started with a 2 to just be 2 times 6. It's not always like that. All right, any questions? Find the sixth term, show solution. They worked it out each time. They just added 2. They went in a lot of detail. Get you there to 12. Final answer is 12. Let's do something else. Okay. Something else is here. Write this example down. This is a different style, a little bit. It's going to be our first geometric style. And I don't know why they do this. The official formula has the R second, right? You guys see this. I wrote down the R second. But what they'll do is they'll write it like a coefficient. I understand kind of why they do it. I just wish they didn't deviate from the formula at all. So this value, when it's a multiplication times that previous term, that's where you'll find the pattern number, R. R is just whenever you're doing multiplication or division. So we need to identify the pattern, identify where you start, and identify where you're going to. Okay? So first, our pattern is what?
A.
It's -3, and it's multiplication, okay? When it's right side by side, it's saying -3 times a subscript n minus 1. So you take -3 and multiply it to the term, the previous term, okay? And we got to generate a list. You know, you can do this any which way you want to. You can even do a T-chart, really. Number term, and then 1, 2, 3. We're gonna go to 4 because it says a subscript 4, and then what it is. The term. What is the term? So the first term, they give it to you. They say it's 8. We're gonna multiply by -3. Now these numbers are gonna get big. You're gonna need what? You're gonna need your calculator. So go ahead, multiply by -3. You gotta include the negative until you get to the 4th term. This is just another way we could potentially write this. Using tables is going to be more of our focus tomorrow, but it's just the same kind of information. A subscript 1, 2, 3, and then we are looking for the 4th. The first term they give us is an 8. We've got to find the 4th term on the list. Go ahead, work it out. Do the whole thing. Use the pattern to find the 4th term. What do you got?
For the A4,
Yeah, the 4th term.
I got -260.
-216. Anybody else get that? Oops. Nobody else? You got it? Okay, -216. Let me write it better. 216. Okay. We'll clear this thing out. See what they got. They multiplied by the -3 each time. They got -216. Good job. Does everybody understand the premise for what we're doing here? Okay. Let's see if they've got anything more confusing than that. They're not even multiplying by fractions. Okay. Next style of recursive. Oh gosh, I don't like this one. I'm pulling it. We're not doing that style. Okay, we're gonna write the recursive type. When I looked at the problems before, they didn't have that one there. That one has something squared. We're not doing that. That's not level appropriate. Okay, so we're gonna write the recursive formula for this one. I need you to identify the same three things. I see the scrimstone faces. It's not as bad as you think it is. You need to find the first term. That's part of it. You need to find the pattern. And then we just write it. Write the answer. Write the equation. It's not nearly as complicated as you think. This might be even easier. What's the first thing, Ethan? What's the first term? Say it again, please. 18? Yeah. So all you gotta do is you gotta write 18. Okay, what is the pattern?
4.
It's going up by 4. So you put the term, put a +4, and you're done. Sounds easy enough, right?
Yeah.
I think so. You can find the common difference by subtracting the second term from the first term. Do you remember this part I wrote in red last week? You'll take the second term, take away the first one. Oh gosh, yeah, my bad. So 22 minus 18, 26 minus 22. If they're a match, you know it is common difference. You know it is a D value. And so that's how you can make sure that you get the right number there, okay? Which style do you think this one is?
geometric.
Why? What's one of the giveaways that this is geometric?
Because the numbers are spread apart. Like a lot.
They are. Also, they're changing signs. And that only happens so if they alternate signs, plus, minus, is being multiplied by a negative. So, that's what I was writing up here on the board. If the numbers are alternating signs, it has to be some kind of multiplication, so you know it's got to be geometric. Now, it's okay if it goes from negative to positive, -3, +1, +5, +9. I'm going +4. It only changed once. But if it's changing every other, then you know it's got to be geometric. Okay? So we're at geometric. How do we find the pattern then? We know it's some kind of multiplication.
You turn the numbers into fractions like -15 over 5 and
Yes.
-135 over
Exactly. Use one of the terms and then use the previous term and put it underneath. And it should be equal to the same thing for the others. This time we use 45 and the -15.
3.
And you get -3 for them all. And so you know you found the pattern there, the common ratio, okay? And writing this equation is also just as easy as the first. You'll just say, okay, I need to have the place I started with. I started with a 5. We have the a subscript thing, the previous term, and it's multiplied by -3. That might be the easiest way to write it. Otherwise, I think you would do a parentheses -3. Let me see if they take that. Whoops. Let me see if they accept this. They should, but I want to see if they do. Okay, yeah, they'll accept that as well. You could put the -3 in front or behind. You might want to use parentheses if you put it behind because it could look a little wonky. But does anybody have any questions? This is really a rehashing of what we've done before. I think 10 and 10 is probably good. Let's go with that.